Okay, so what we're going to do is just basically review a little bit of our quadrilateral properties. I know it gets kind of confusing when we talk about, like, when we say, like, rectangles are also parallelograms, and squares are also rhombuses and rectangles too, right? And so it's like, and what properties are what, as far as like, okay, does a rectangle have this kind of property or whatever? So I want to spend a little more time just looking at those properties and stuff, getting that practice in, okay? So, sorry, on page 461, we're at the top on page 461, all right? So, we want to be able to identify things. So, again, talking about rectangles. So, parallelograms, all right, if we review parallelograms here, I'll put that up on the board, all right? A parallelogram has, like, it is what it is kind of by its word, by its name. A parallelogram has the word parallel in it, right? And so it's a quadrilateral with two pairs of parallel sides.
And the legs are not congruent.
So in a parallelogram, we don't have legs necessarily. We only have legs when it comes to trapezoids. So the properties of a parallelogram, so for example, what's true about the opposite sides of a parallelogram? What's be true about the opposite sides? Besides them being parallel, what else would be true? So yeah, opposite sides are congruent. Okay, what about opposite angles? If you want to have it down somewhere, yeah, I'll leave it up on the board for today, but if you want to write it down somewhere. In a second, we'll get to that. Sorry, opposite sides are congruent, and then what about opposite angles there? Sorry, what? Opposite angles are congruent. Yep. Means the same thing. And then we have one more thing about parallelograms, the diagonals. What do the diagonals do in a parallelogram? Yes, the diagonals bisect each other. Okay? Those are like the main properties there of a parallelogram. All right? And if you have a quadrilateral that has one of these properties, that means your quadrilateral is a parallelogram. So by definition, a parallelogram has two pairs of parallel sides. However, if you have a quadrilateral that has opposite sides congruent, so for example, does a square have opposite sides that are congruent? It does, so therefore a square is also a parallelogram because it has that property. Okay? Does a rectangle have opposite angles that are congruent? What are the opposite angles in a rectangle? They're all 90 degrees, so yeah, so a rectangle is also a parallelogram. Any of these properties here, if they're true, that makes your shape a parallelogram. Okay?
Don't they need, like, all of them, though?
Or quadrilateral, sorry?
Don't they need all of the properties?
Well, if they actually, it turns out, if it's quadrilateral and they have one of these properties, then all of them will hold true. Like, they're all kind of like, if you have this one, then you'll have this one, this one, this one as well. Guaranteed. It'll always be true. You can try to give a counterexample if you want, but it'll actually work out. Okay? Now, rectangles, and that's right here, okay? When we're given a parallelogram with certain properties, we can use the properties to determine whether the parallelogram is a rectangle, okay? So, conditions for a rectangle. So what makes a parallelogram more specifically than a rectangle? So, if one angle of parallelogram is a right angle, then the parallelogram is a rectangle, right? So here we have a parallelogram. You can see by the opposite sides being parallel. If one of these angles is a right angle, that means the whole thing is a rectangle. Why is that? Well, let's think about this. If angle A is 90 degrees, and this shape's a parallelogram, what does that mean angle C has to be? Got to be 90 degrees as well, right? And then if A and C are both right angles, B has to add up with angle A to make 180. So if A is 90, what does that mean B has to be? 90 as well. And if B is 90, then opposite that has to be 90 as well. And so we get a rectangle just from knowing one angle being a right angle.
So when I was working on this yesterday, so in a shape on a segment, does that segment add up to 180 degrees?
So it depends on what you're measuring. Like if you have a 180 degree angle looks an awful lot like a segment, right? Like that. So this is technically a 180 degree angle, but you could also name it as a segment, like AC, if you wanted to.
So each segment has to add up to 180 degrees. Right?
Well, so I want to be careful about that. When we're talking about segments, we're talking about a length, not an angle measure. So AB, AC, BC, those are all lengths. You're measuring from here to here, like inches, centimeters, whatever. When we talk about angles, we're talking about degrees. So the angle ABC is, yes, 180 degrees. But you wouldn't say that angle AB Because you never name an angle AB. You never name an angle BC. You would name it ABC there. That's fine.
ABC is 90.
This is 180 because it goes
No,
from...
you said angle ABC is equal to 180.
That's right. I'm talking about this angle ABC right here.
So that's
Thi-
different. You said it was a line.
Okay, it's also a 180-degree angle if you name it. Angle ABC, that's also an angle, 180 degrees, because it's exactly a straight line. Angle. This, however, angle ABC here, you're right, and this, for this
Then
one.
how do you tell the difference between angle ABC and ABC?
Angle ABC here is clearly a right angle, right? We're using our properties. Angle ABC here, if you're asked for angle ABC, then it's clearly a 180-degree angle because it's straight. Okay, so that was properties for rectangles, folks. So if you have one right angle in your quadrilateral and the quadrilateral is a parallelogram, then the whole thing's a rectangle, okay? One right angle in a parallelogram makes it a rectangle. And then also, another property of rectangles, right? What's true about the diagonals in a rectangle? Well, what does it look like is going to be true here? BD, how does it look like it compares in length to AC? They're going to be equal, yeah. And so if the diagonals of a parallelogram are congruent, right, the diagonals of a parallelogram already bisect each other, but if they're also congruent, the parallelogram is a rectangle. That's enough information to say that. Okay? So, so let's look here at the next page on page 462. So this is kind of like how we want to use that information. So it says, the directions say, use the given information to determine whether the quadrilateral is necessarily a rectangle. So like the information we're given, must this shape be a rectangle? Now you look at the picture and you say, Mr. Widmeyer, that looks like a rectangle. All right, I've learned about rectangles since probably before elementary school, probably like pre-K or something like that. I learned this shape was a rectangle. That looks like a rectangle, it's a rectangle. But now that we're in geometry class, we want to be more precise. Yeah. Okay, now that we're in geometry class, we want to be more precise. We want to make sure our properties match up. So let's look at what we're given here. For number 4, we're told that this is just a quadrilateral, first of all. So we're not told it's a parallelogram, it's just a quadrilateral for right now. Okay, we have to kind of use the information we're given now to figure out the rest. So let's see here. We're told that EF is congruent to GF. So here's EF, and that's the same thing as GF. And you're looking at this, and you're like, Mr. Widmeyer, there's no way those are congruent. EF is this little short side, and GF is this big long side here. But that's what we're told, so we're going to mark it that way. Okay? We just, I guess, the picture's not drawn to scale. Okay, it's not drawn accurately, so we have to kind of like trust, you know, what the information we're given here. We're also told that FG, so that's this segment, is congruent to HE. So that's this segment right here. So that means FG, right, which is the same thing as GF, is congruent to HE right there. And then lastly here, we're told that FH is congruent to GE. So let's see here, the diagonals. Okay, so like those two, like that. Okay, they're different. All right. So, yes, Haley?
Wouldn't that be like a square if one of the sides are like congruent?
So, well, let me see here. So, all the sides are congruent. So, not all the sides are congruent, though. That's the trick, right? We don't know anything about GH.
But is it possible for that to be like different than the other 3?
Yes, and I can actually like think of a picture right now that would make this so. This is not, remember, this is not drawn accurately, so you have to be very careful. So first of all, folks, is this shape a parallelogram? Do we have any of the properties of parallelogram up here?
Yes.
For example, can we say that opposite sides are parallel using only the given information?
No.
Yeah, not really, right? We're not told anything about parallel here, and there's no like way we kind of say they're parallel just by length. Let's get the next property. Are opposite sides congruent in this quadrilateral? Well, we have one pair of opposite sides, but we don't have the other pair. We're not told that. And then we don't know anything about opposite angles. Okay, they look like they're congruent, but we're not told that, so we can't use that information in this case because we need to only use the given information. And then the diagonals, do they bisect each other? Well, it kind of looks like that, but again, we don't know. Now, the diagonals are equal here, but we're not told that. So this shape's not necessarily a parallelogram, and so must it necessarily then be a rectangle?
So if you don't know, like, what it is in the classroom.
Yeah, here we don't have enough information. Okay, not enough information. We don't have enough information here to conclude that it is a rectangle. Now, what additional piece of information here would allow us to say this shape is a parallelogram? Yeah, if FE was congruent to GH here, if all four sides were congruent like that, then we would have opposite sides congruent, it would be a parallelogram, and then it would also be a rectangle because the diagonals are congruent. And so all we need is just to know that GH is congruent to FE here, and we'd be good to go. It would be a parallelogram, and then because the diagonals are congruent, it would also be a rectangle. But since we don't have that one piece of information, we can't say. And in fact, I can kind of draw a picture of a situation like this where it would not be a rectangle, okay? And that would be, it's an isosceles trapezoid, basically. I gotta be really careful about how I draw this, but... Okay, I didn't do a very good job, but you get the idea here. I can say that these three sides are congruent, and I can even say that the diagonals will be congruent. Okay, so that kind of like matches this picture, although, you know, this one's not drawn to scale, but this one's more drawn to scale. The diagonals here would be congruent. I can make all three of these sides congruent, but this fourth side won't be, and that's not, you know, a rectangle. So, yeah. Anyway, now let's go to this next one here. So in this next one, we're told that FEG, this angle right here is 45 degrees, and that GEH is 50 degrees. Okay, so again, we're going to cross out these other pieces of information here now. Okay, so all we're given are these two angles right there. Okay, is this quadrilateral necessarily a rectangle, given that information?
No.
Why can't it be?
You can tell if it's a rectangle, but it's not a rectangle.
How? Oh, so yeah. So why isn't it a rectangle? What with just these two angle measures? How do we know the shape cannot be a rectangle?
It's 95 degrees.
Yeah, 45 plus 50 is a 95-degree angle. Do rectangles have 95-degree angles? No. Okay, so not a rectangle. Okay, because the shape has a 95-degree angle. Okay, so it makes it not a rectangle. It does not match our properties. Rectangles have to have 90-degree angles. Okay, E will be a 95-degree angle. No good. Okay. So that's the idea there. Okay, but here's the thing. Even if angle E was 90 degrees, we still wouldn't know anything about FG or H, so we'd still be kind of stuck there. But we can say for sure it's not a rectangle because the shape has a 95-degree angle, and no rectangle has a 95-degree angle. All right, so that's kind of how we're going to use those properties there. So again, rectangle. Okay, the rectangle, by definition, it's just an equiangular quadrilateral. Okay, the properties of a rectangle, the diagonals are congruent. All right, and it has all the properties of the, I guess that's it. That's just it. The diagonals are congruent there. Because it also has all these other properties too, from the and parallelogram properties. Okay, so it has all those. All right, our last shape we're going to look a little more in depth at, just to kind of review a little bit, is the rhombus. Okay, so the rhombus, you can also use given properties of a parallelogram to determine whether the parallelogram is a rhombus. All right. So, for example, if you have a parallelogram, okay, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Okay. Now, by definition, what makes a rhombus a rhombus? Okay. A rectangle is an equiangular quadrilateral. A rhombus is a what? Equilateral quadrilateral. So why is it enough? Why is it enough to say that if we have one pair of consecutive sides congruent, that all the sides will be congruent in this parallelogram here? Okay. Right. If this shape's already a parallelogram and you have a pair of consecutive sides congruent, what do we know GH is going to be equal to? If this shape's a parallelogram, what does GAH have to equal? in this shape, what else does GH have to equal? EF. Yeah, they're going to be congruent. Opposite sides will be congruent. And then FG will have to equal EH. And so then since all four sides will be congruent, that makes it a rhombus. So one pair of consecutive sides make this thing a rhombus. Okay? Also, another property of a rhombus, the diagonals of a rhombus are perpendicular. So if you have a parallelogram whose diagonals are perpendicular, that shape is really then also a rhombus. Okay? So perpendicular diagonals, so I'll put that up here. So the property, perpendicular diagonals. Okay? So again, parallelogram with diagonals that are perpendicular. Okay? That means that's a rhombus. And then lastly here, if one diagonal of a parallelogram bisects a pair of opposite angles, so for example, this diagonal here, it cuts angle F into two smaller equal angles, and cuts H into two smaller equal angles, that makes this shape a rhombus. Okay? So the diagonals bisect opposite angles. And so let's take a look at that. Alright, let's see. I think I've got... Oh, actually, I don't think there's any property. There's not. There's no practice with that one. So anyway, all right. Okay. And then, of course... Oh, yeah, we'll look at this one. Look at this one. Okay, sorry. Yes, we'll look at this one. So page 464, turn the page there to 464. Okay, let's just take a look at this one. Okay, and this one's pretty, intense as well. But this will be like the last one maybe we look at here, okay? And I'll give you guys some practice to look at. Actually, you know what? I don't know if I like that one. We might... Yeah, we'll skip that one. Forget about it. Never mind. Move on to 466. We'll go into the little homework assignment here, and we'll take a look at some of these, because I think that'll be better. Okay? Sorry about that. This will be better. Okay. So the directions here on page 466, we're just going to try some of these practice problems here. It says, determine whether each quadrilateral must be a rectangle. Okay? So what makes a rectangle a rectangle? We either want to show that all the angles are equal in the quadrilateral, or we want to show that the diagonals are congruent. Okay? Or, of course, you can use some of the parallelogram properties there to help us as well. Okay? So we look here. Number 3. We're told that BD is equal to AC. Okay? So must this quadrilateral then be a rectangle?
Yes.
Yeah, exactly. Yes. What's the reasoning here? The diagonals are equal. Okay, that's a property of the rectangle. And so, yes, the diagonals are equal. Since this shape is a rectangle, what other shape could we name it? A parallelogram, okay? Because the shape's a rectangle is also a parallelogram. So this is also a parallelogram. Now, that's not part of the question, but that's just what we had to say there. Okay? And let's get number 4. Okay? So number 4, we look at the shape here. So the only given information is that all these sides are congruent. Okay? And it looks like it's a square, but again, that's all the given, we can't really assume these are right angles, okay? They look like right angles, but because we're trying to determine whether this quadrilateral is a rectangle or not, we can only go by the given information. We can only use this given information right here. Okay? So is this a rectangle? Must this be a rectangle?
No.
Yeah, no, right, okay? Why do you say that, Kyle?
Because a rectangle doesn't have all the equal sides.
Okay, right, and we don't know enough to say whether these angles are all congruent. Oh wait, actually, let me think. Yeah, we don't know if they'll say all that.
But if all the sides
Listen
are
up, guys.
congruent, then how do you make a shape where all the sides are congruent but don't have equal angles?
Great questions. And can someone answer that? So, what kind of shape has all 4 sides equal but not all 4 angles equal?
Oh, never mind, that's a rhombus.
It's a rhombus, that's right. So this shape is not a rectangle, but we could call it a what? It's a rhombus. So it's not a rectangle. Not necessarily a rectangle, I'll say. We would need more information. A square is a rhombus. Mm-hmm.
But a rhombus isn't a square.
Not necessarily, right. It's like a rectangle is a parallelogram, but a parallelogram is not necessarily a rectangle, right? Special types of parallelograms are rectangles.
Okay, so like you don't have to tell if it's a rhombus, you just have to say not necessarily a rectangle because that's what the question's at.
Yes, exactly. Yeah, it's not necessarily a rectangle. We just don't have enough information there. I'm not sure about the explanation. We just don't have enough information there for that. Okay? All right, now let's go to the next set of problems up here, and this will be a little more helpful. Okay? Now we're told that each quadrilateral is a parallelogram, which means since this shape's a parallelogram right here, we have two pairs of parallel sides. We have opposite sides congruent, we have opposite angles congruent, we have diagonals that bisect each other. Okay? So now looking at this shape, we have one additional piece of information. The diagonals form what? They're perpendicular. So is this shape a rhombus? Yes, because rhombuses have perpendicular diagonals. So yes.
How do you know they're perpendicular?
Great question. Look at the picture. What's marked in there that tells us that those diagonals are perpendicular?
I mean, yeah, like the 90-degree angle, but they could also be congruent.
So, you mean congruent in length, you mean, for the diagonals?
Yeah.
Yeah, they could be, but that's not enough. All we're trying to determine is just, do we have enough information to say it's a rhombus? If we do, the diagonals are perpendicular, so therefore we can say it's a rhombus. And so we can stop there. We don't have to worry about other stuff. Okay?
Alright, just like some shapes, like, you have to follow all the properties.
Right.
Like, how do you know which shapes follow all the properties and which shapes not?
So in this case, we're just trying to determine whether, using this given information, is this shape a parallel, or is it a rhombus? Okay? And so, since this shape is already a parallelogram, right, we're told here, each quadrilateral is a parallelogram in this case, must it be a rhombus then? And so we already have all those parallelogram properties because the shape is a parallelogram. And we just have to say, then do we have the additional property of perpendicular diagonals? If we do, that means then we already have the diagonals bisect each other, or bisect opposite angles and stuff like that. That'll be true also. Okay?
Like, what if you get to like a shape on a test, but it follows one property, but it doesn't follow the other property?
Then, so it depends, again, on where we're going. So, for example, here, this one follows the properties of a rhombus, and a rhombus is not necessarily a rectangle, right? They don't have necessarily the same properties. But this one, the diagonals are equal, making it a rectangle. Therefore, also, because a rectangle is always a parallelogram, this shape is also a parallelogram, guaranteed.
Right, but like for a trapezoid, like if it was a non-isosceles trapezoid, the non-isosceles just doesn't follow one rule.
Right, exactly. The non-isosceles trapezoid really is kind of like a shape kind of like unto itself almost. It's kind of like...
Okay, so what if you come upon a shape that has one of the properties and not the other properties? So
then it can't be that shape. But I don't think, like, for example, in a parallelogram, if you have opposite sides are congruent, you will be guaranteed.
Well, I know the parallelogram, but like a rhombus,
okay,
or like a rectangle, like what if you have one property but you don't have the other property?
That should not happen. There's an error somewhere because, again, even same thing for the rhombus. If the diagonals are perpendicular, then the diagonals will also have to bisect opposite angles in the quadrilateral. I don't think you can have perpendicular diagonals without also then having the other stuff there.
So how do you know if the diagonals bisect opposite angles?
Well, again, in this case, we're not told enough information, but we know it's going to be true because this shape is a rhombus. They will bisect each other.
Yeah, but like
how will it be marked in? You would see something like this.
Okay. But like those aren't all the equals.
No, but right. I guess I do this one too.
What if they give you something like that without all the angles?
So without all the angles, then you wouldn't have enough information. You'd say not enough information. Okay, number 6 here. Sorry, guys, we're moving on. But those are good questions because we want to make sure we iron this stuff out. Okay, and then we'll probably call it quits after this one. I'll give you guys your assignment. So number 6 here. Okay, number 6. We've got this quadrilateral. It's a parallelogram, which means opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. So since this shape is a parallelogram, we have these two sides congruent. Well, what will this side? What must be true about this side? It's going to be congruent to this opposite side here because opposite sides are congruent in a parallelogram. Again, we're told it's a parallelogram. And then what about this side? Also must be congruent. So is this shape a rhombus? Yes. And why? All sides are equal, yeah. Equilateral. Equilateral quadrilateral is a rhombus. Okay? So there it is. Okay? I'm not going to give you guys, I'm going to give you guys some practice now at this, alright? Some of it involves like calculations, some of it involves this kind of logic stuff, but it won't be all this kind of like heavy kind of logic stuff. But I just want to get us practice these properties so we can have them down. Okay?